You're going to need multiple nodes in the output layer. And in some cases, you're going to have a lot of nodes in the output layer, right? So yeah, what do you guys think? Let me know if you know what a dropout rate is. Put that in the chat. And yeah, while you're thinking about that, let me focus on the dropout rate. So, because Starry Vibes has already given an answer. Starry Vibes says, I think it's used to reduce the complexity of the model. What do you guys think? Does anybody agree with Starry Vibes? Yassine says, what percentage of nodes to turn off in each layer? Okay, why would you want to do that? Why would you want to do that, Yassine? Denelson says, I have defined dropout rate as the proportion of nodes that my model will sleep to help with the complexity of the model. Okay. Denelson and Starry Vibes, maybe you guys can give me a definition for what you mean by complexity of the model, because that's where I'm stuck. I think you guys are generally on the right track, but you're losing me at complexity of the model. Osama says it's a regularization technique used in neural networks to prevent overfitting. Aha. Overfitting, right? I mean, that's pretty important, right? You know, just as we talked about on our previous meme, right? You don't want to get everything because then you're just overfitting, right? So how do we account for overfitting in our models? Like how are we going to prevent that ourselves? Right? Kind of an important discussion. Manoj says used to prevent overfitting. Yeah, yeah. See, so Starry Vibes and Denelson, that's kind of where you lost me, because I don't view it as complexity. I view it as the overfitting. Right? So Manoj says agree with Osama. Yeah, and Manoj, I think Osama would also agree with you. Yassine says, I want to do that to make sure the model does not unnecessarily focus on the very small details. Oh, Yassine, but what is small? What is small? The neural network doesn't know that, right? The neural network doesn't care. Yassine, buddy, I love you, but I'm not on board with that answer. Starry Vibe says high complexity is more flexible but risks overfitting. I'm not sure if I associate complexity with overfitting though, Starry Vibes. Complexity is going to affect your speed, the size, like the physical size of the neural networks, but overfitting, I don't know about that, Starry Vibes. Denelson says we use dropout rates so that we can help our model nodes don't grab all the information. As non-information can be best. That can help us with reducing overfitting. Okay. So Denelson, I think you're putting forth a very reasonable definition there. So here's how I like to think about it, guys. Remember how we've talked about that a neural network is a mathematical representation of the human brain, right? That's the base definition we've established. So when I think of a dropout rate, I think of those times when you're just like, oh, wait, what was that? What was that person's name? Oh, wait, where did I go on vacation that one time? You forget things, right? We talked about those synapses and all the links in your brain. Sometimes those links don't work, right? Sometimes things just kind of get lost, right? So a dropout rate simulates that in training, right? Because it's a training hyperparameter, right? You really wouldn't need it at runtime. And that's where you simulate nodes dropping out, because that kind of simulates a little bit of a memory loss, a little bit of just like times when like your brain has to think about other, oh yeah, now I remember it, right? Has to find other patterns or other connections in your brain and in those connecting synapses to be able to say, oh yeah, now I know the answer, right? That's basically what a dropout rate is. It simulates that. it says, okay, this training round, I want to shut off X number of nodes, or proportion of nodes. And that way the network has to kind of retrain itself and say, oh, here's what I need to do to get to an answer, right? So that's really how I think about it. The benefit is that it prevents overfitting, right? Why? Well, because it has to find other ways to an answer, right? And you're forcing it to adjust. You're forcing it to say, okay, yeah, well, in times when you don't know this, or in times when you get a bad answer here, make sure you find an answer by going over here, 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 and here, right? So that's basically how I think about a dropout rate and the benefit of it. Because you are preventing that overfitting, because now when you present data, it's kind of sorted to a different neural network every time, because different nodes will be shut off, right? Same proportion of nodes, but that's kind of the point, to help you have different neural networks answering the same answer on the same data. Manoj says, I feel complexity can be addressed as high dimensionality, open to being wrong. Manoj, I want to credit you for saying open to being wrong. I think that's a very healthy attitude for a data scientist to have. So good for you, my friend. Complexity can be addressed as high dimensionality. Sure, sure. High dimensional models tend to be complex. So I agree with that, but it's not the only source of complexity. Remember how we talked about the neural network architecture can be whatever you want it to be, right? There's different implications of your choices, right? If you need it to be a fast neural network, or it can be a little slower, or you're going to have a lot of hardware, you're going to have a little bit of hardware. There's implications to those choices, but complexity can also be addressed or created by the architecture that you choose, right? So I think you're on the right track overall there, Manoj. Fabrizio says the model becomes more resilient and flexible. Drop rates, the dropout rate is the fraction of neurons randomly set to 0 during each training step. Yeah, that's reasonable. Yeah, guys, and if it's very important how we express ourselves, right?